Hi everyone! Today we're going to start a new unit on quadratic functions. And you've heard of quadratic functions before when we were talking about systems of equations and we had to graph a linear function with a quadratic function and find where they intersect. So what we're going to do in this unit is really go a little bit deeper into what a quadratic function is and all of the features of those functions. So today is all about learning the vocab that goes along with quadratic functions and all of the key features of them. So if you look at the graph that I've given you, you can tell this is a quadratic function because of the parabolic shape of the graph. So remember, a parabola is a U-shaped graph, which is what a quadratic function looks like. I know it doesn't show it on the graph, but I want you to realize that this graph does go on forever, all the way to positive infinity. So I'm just going to add some arrows in here. So if we look at the very first question, it says, what is the axis of symmetry? Now when we were doing linear systems and linear quadratic systems, we talked about how it was important to find the axis of symmetry anytime we graph a parabola. And the reason we do that is because that tells us where the turning point of our parabola is. And that turning point, or vertex, is important because if we didn't know what it was, we wouldn't know exactly how high or how low that parabola goes. So in our linear systems unit, we talked about using the formula x equals negative b over 2a, and that's one way that we can find the equation of the axis of symmetry. But if we're just given a graph and we don't know what the equation of that function is, we can actually just look at the graph to get the axis of symmetry. So if you think about where that parabola would fold so that it overlaps on itself, I'm going to draw in that line right on the graph here. And so this line that I'm drawing in is the axis of symmetry. It goes right through my turning point or my vertex. And if I were to fold the parabola on that line, it would overlap onto itself. And so what we need to do is we just need to write the equation of that line. So remember, any line with an undefined slope is going to start as x equals. And if we look, that line goes through 0 for my y coordinate and 2 for my x coordinate. So the line would just be x equals 2. I'll just label that on the graph. And so that's how I find the axis of symmetry without knowing the equation of that function. We just draw it in and we know that it's always going to be an x equals line. So for b, it says, what is the vertex or turning point? Well, we already drew that in right here. It's the point that the axis of symmetry goes through. So if I find the coordinates of that point, I'm going over 2 and down 2. So 2, negative 2 would be the turning point, or the vertex. And because this parabola opens upward, we would consider the vertex to be a minimum. It's the lowest point on that function. For D, it says to state the x and y intercepts. So we've been talking about intercepts for much of this year. So let's start by finding the x-intercept. So on the graph, I'm just going to put points where this parabola crosses the x-axis. So the first x-intercept, I'm just going to write this out here, would be 1, 0. But we have another one, and that one is 3, 0. So again, the x-intercept is where that function crosses the x-axis. So now to find the y-intercept, we're going to look for where does the function cross the y-axis, which is right here. 1, 2, 3, 4, 5, 6. So 0, 6 is our y-intercept. So you're going to notice that a lot of times parabolas will have 2 x-intercepts. Not always. If the vertex happens to be on the x-axis, then there will only be 1 x-intercept. But most of the time, we'll see 2. So what that means is that there are actually 2 solutions to the quadratic equation. So I don't know if you remember talking about how sometimes quadratic equations will have 2 solutions or one solution or no solution. Two solutions means it crossed to the x-axis at 2 points. One solution means it crossed the x-axis at 1 point, meaning it was probably the minimum or the maximum. And if it doesn't cross the x-axis at all, it's because the roots were imaginary. So if you remember quadratic formula, if we ever got something where there was a negative under the square root and we said there were imaginary roots, that means that parabola is kind of floating up, maybe in the first quadrant, and it's never going to cross that x-axis. So for part E, it says to state the interval over which the function is increasing. So again, we've done increasing and decreasing before, but just as a reminder, when you're doing that, you want to make sure you're looking at your domain values when you're going to write this down. So the function is increasing when x is 2 all the way to infinity. So I'm going to say between 2 and infinity, my graph is increasing. And remember, we never include the numbers, meaning we're never going to use brackets because it's between those numbers that the function is increasing. At 2, it's doing neither. It's not increasing nor is it decreasing, so we don't want to include it. So to figure out where it's decreasing, we're kind of going to do the same thing. So reading the graph from left to right, we can see that all the way from negative infinity to 2, our graph is decreasing. So we're going to write from negative infinity to 2. Part G says state the domain and range of the function in interval notation. So thinking about the domain, remember that means how far left and right does your graph go? Well, since our parabola typically goes out to the sides forever with the arrows on the end, we can say that our domain would be from negative infinity to positive infinity. So it covers every value of the domain. It covers every x value. And then our range, we want to think how low does our function go and how high. So the lowest it goes, we have already seen from our turning point, is negative 2. And the highest it goes is infinity. Now, because there was a point at negative 2 on the graph, we want to make sure we include that number in our range. But remember, we never include infinity or negative infinity when we're talking about domain and range. Okay, so let's go to the next one. And this question is going to be a little different because now I'm not giving you a graph. All I'm giving you is an equation. And I actually want you to do all of these questions without looking at a graph. Okay, so it's going to require some algebra. So first things first, it says, does the parabola open upward or downward? And explain. So you may have already noticed this from other parabolas that we've dealt with, but in order for a parabola to open upward, the a term of your parabola needs to be positive. If the a term is negative, your parabola is going to open downward. So if you look at the equation that they've given us, remember the a term is the coefficient of x squared. So in this equation, a is 1. And since 1 is a positive number, we can say that our parabola is going to open upward. And we can say because the a term is positive. You could also say opens upward because the leading coefficient is positive. That's another way to explain it. So whatever you're comfortable with. For part B, it says, what is the axis of symmetry? So we've done this before when you've been asked to graph a parabola by hand. So if you remember, our axis of symmetry formula is negative b over 2a equals x, because it's the equation of a line. So going back to our equation, the b term is the coefficient on the x term. So b is negative 2, and c is our constant term, so negative 8. So if I plug that in, negative negative b is actually positive 2 over 2 times a, or 2 times 1. And 2 divided by 2 is 1. So our axis of symmetry is x equals 1. So remember, that's the line that goes through the turning point, and it makes it so that the parabola is symmetrical. So part C says, what is the vertex? Well, remember, because the axis of symmetry runs through the vertex, we know that the x-coordinate of the vertex is going to be 1, because it has to be if it goes through that point. So to get the y-coordinate, we're going to actually just substitute 1 into our equation and figure out what y would be. So I'm going to take our quadratic equation from up above, and I'm going to substitute 1 for all of my x values. So this is going to give me 1 minus 2 is negative 1, and negative 1 minus 8 is negative 9. And so I know that my vertex would be 1, negative 9. Now the second part of this is that vertex a maximum or a minimum? Well, if you think about it, we said that our parabola is opening upward, which, remember, opening upward would look like this. And so if it opens upward, that parabola is going to have a minimum. So that's how we know that this point is a minimum and not a maximum. If the parabola were to open downward, our turning point would have been a maximum. Okay, so x-intercepts. How do we find those from an equation? Well, if you think about what an x-intercept is, it means that your y-coordinates are going to be 0. So using our equation, if I plug in 0 for y and I solve for x, I will get the x values where it crosses the x-axis. So I'm going to take my equation again, but this time I'm substituting 0 in for y. And I'm left with this quadratic equation to solve, and we've done this numerous times, so you have options. You can try and factor, you can complete the square, you can do quadratic formula. I would suggest trying to factor first, which this one, if I'm thinking of what multiplies to be negative 8 and adds to be negative 2, I can use x minus 4 and x plus 2. So remember, we split that down the middle and we solve each side. So I get 4 and negative 2. So the x-intercepts would be 4, 0. Whoop, my pen went crazy, sorry. And negative 2, 0. So there are our x-intercepts. Part E, what is the y-intercept? Well, kind of the opposite of the x-intercepts. If you think about where your function crosses the y-axis, it's somewhere where x is equal to 0. So what I'm going to do is, instead of putting 0 in for y, I'm going to put 0 in for x. And so when I solve that, I'm going to get that my y-intercept is negative 8. So this would be 0, negative 8. Okay, and the last thing we're going to do here is, well, one of the last things is we're going to graph the function using a table of values. So what's pretty crazy is you have a lot of points already just from all the work we've done, but we'll practice putting this in our calculator and getting our table of values. Now remember, one of the most important points on your table is your vertex, your turning point. And so we've already found that to be 1, negative 9. So we're going to make that be the center of our table. So get this drawn here. I already forgot what it was. 1. So it's going to go in the middle. And then we want to choose some values surrounding that. Okay, so take a second. Let's put that in our calculator. So remember, you're going to open a new graph page. And we're going to type in our equation, which was x squared minus 2x minus 8. We're going to pull up our table by pressing Control T. and we're going to copy down what our table is. So when x is negative 2, y is 0. When x is negative 1, y is negative 5. 0, negative 8. 1 we already knew is negative 9. And then here's that characteristic of a parabola where your y values are going to take on the pattern where they go in the opposite direction again to show that it's symmetrical. So there's a complete table. And then go ahead and plot those points. Forget to label. And there's a complete graph. Now we probably could have put some other points if we wanted. It looks like we could have done 5, 7, and negative 3, 7. But that's okay. This is enough points if you did stop there. Okay, so then part G, the last part says, state the domain and range of the function as an inequality. So in the last example, we did the domain and range in interval notation. So this is a little different. So let's talk about the domain of this. So it's very similar to the domain of the first one because it covers all the x values. So we would normally say from negative infinity to infinity if we were doing interval notation. But since they want it as an inequality, you actually have a couple choices. We talked about before how it's okay to just say x is an element of the real numbers, meaning basically it can be anything. Sometimes we've also written it as an inequality that looks like this, where we say it's between negative infinity and positive infinity. So I am okay with you writing it either way. For the range, we want to say, okay, the lowest it goes to the highest. So the lowest point I see here is negative 9, and the highest point would be infinity. So again, as an inequality, we would say y is greater than or equal to negative 9. And that's it. Anything negative 9 or above is included in that range. Okay, so the last thing we're going to talk about today with parabolas is something called average rate of change. Now, we've learned about slope before. Okay, so it says finding the average rate of change or slope of a quadratic function requires you to look at specific intervals. Use the graphs of the quadratic functions below to find the average rate of change for the following intervals. So the reason why we really don't call it slope is because it's not constant. So with a line, your rate of change is constant. No matter where on that line you choose to find the slope, it will always be the same. But in a quadratic function, because it's a curved, it's nonlinear, our rate of change is not the same. So you have to be given an interval to figure out, what part of your graph are you finding the rate of change for. So in part A, it says that we need to find the rate of change over the interval negative 1 to 0. So when they say that, they're referring to the x values from negative 1 to 0. So if you look at the table that's next to the graph, I'm just going to kind of highlight the 2 points we're looking at. They're basically saying, find the slope between those 2 points. And so we're going to treat this just the same way we would find the slope of a line. We're still going to say the change in y over the change in x, or y2 minus y1 over x2 minus x1. So if I do that, I'm going to start by saying, okay, the difference in my y values, minus 3, over the difference in my x values. And remember, whatever order you choose for your y values, you have to do the same order for your x values. So on the top, I'm going to get 5, and on the bottom, I'm going to get negative 1. And when I divide that out, I get negative 5. So the rate of change between that x value of negative 1 and the other x value of 0 is negative 5. So let's do it again now over the interval 0 to 1. So again, over on my table, I look, okay, those are the 2 points I'm dealing with. So the change in y would be 3 minus 0. and the change in x would be 0 minus 1. And so the average rate of change on that interval is negative 3. And we can keep going. Now I'm looking at the rate of change between 0 and 3. So now these points are not next to each other, but we still do it the same way. So 3 minus 0 over 0 minus 3. Rate of change is negative 1. Okay, over the interval from 1 to 3, looks like for my y value, 0 minus 0. On the bottom, 1 minus 3. 0 divided by anything is 0. And let's actually look at that for a second on the graph. So if I'm looking at the x value of 1 versus the x value of 3, do you see how the rate of change between those 2 points, the average rate of change I should be saying, is 0? There is no change if I'm just looking at those 2 points. So it makes sense that it averages out to be 0. Okay, so we're going to do the same thing with this parabola. So this parabola is opening downward, but we're going to treat it the same way. So average rate of change between negative 5 and negative 4 means I'm going to use those 2 points. Negative 5 minus 0, negative 5 minus negative 4. Be careful with the extra negative there. This gives me negative 5 over negative 1, which is positive 5. Okay, we're going to do it again for negative 4 to negative 3. This gives me negative 3 over negative 1, which is positive 3. And then we have another interval, negative 4 to negative 1, so those 2 points, 0 minus 3, negative 4 minus 1, gives me an average rate of change of 3/5. Okay, we have one more, negative 3 to negative 1. So on the top, 3 minus 3. On the bottom, negative 3 minus negative 1, which is 0. Again, that's an interesting one to look at. So when x is negative 3, I'm right here. When x is negative 1, I'm right here. And again, there's your 0 rate of change. So very similar to slope, nothing crazy. You just have to remember when it says average rate of change, you have to know that you're really just using the slope formula. Okay, so those are some really important key features of parabolas, and we will be using them throughout this unit. So it's important to really understand why they're useful and how to find them, both from an equation and from a graph. So you have a page in your packet that shows kind of those key features. I would, take a look at that and compare it to what we just talked about in this lesson to help.